Welcome to Unlocking Science. Our goal is to glorify God by studying and unlocking the secrets of His amazing creation. I'm your host, Mr. P, and today we're doing one of our hands-on activities, and we're going to be talking about a happy heart rate. So hopefully you've seen our videos, our body of evidence videos with Dr. Menton talking about the heart and the lungs. This activity is going to be based around that. So if we think about some of the things we talked about with Dr. Menton, we've got a big model of the heart here. And we talked about how there are different doors and different valves inside of here that let the blood flow through in different sections. All of those different areas are going to help us determine different sounds inside our body and different things that are happening going on inside our heart. Okay, so we're going to be looking specifically at your pulse and your breathing rate. So if we think we're taking in a big breath, the normal rate that we breathe at, if we're thinking about our heart rate, the normal rate that our heart is beating at, those are what we call our resting rates. So we're going to be looking at an experiment where you're going to be determining your resting heart rate. Then you're going to be active for a certain amount of time. You're going to look at how your rate of respiration, that in and out breath that we do, and how your heartbeat changes over time as you're exercising, and how God has created our bodies to be able to adjust both our heart rate and our breathing rate, our rate of respiration, in order to accommodate getting more oxygen into our bodies when our bodies are more active and needing those things. So when we think about your blood vessels that are running through your body, we might think about them like this tube. Now this tube is very rigid and flexible, but if it could expand a little bit, and the heart were sitting down here, we could pump fluid into this, and this would expand a little bit. Imagine one of those balloons that you make animals out of or swords out of. When you pump air to it, it gets bigger as the pressure of the air comes down. And if you were to let off the pressure, it would shrink back down. That's basically what your blood vessels do. They're elastic. And we can take advantage of that to actually feel our pulse. And there are two basic areas on our body that we generally use to feel our pulse. One of them is in our carotid artery area. So if we think about right up here, there's an artery that's running up from my heart, up into my head, and it passes through this section right here underneath of my chin. So if you can feel the side of your trachea, and you bring two fingers in here, and you place them right here, I can actually feel my heart beating and pulsing right here. Now, I'm not actually feeling my heart beat, I'm feeling the blood pumping through those veins, and it's expanding that artery as that happens right there, and it's going up in the arteries and then coming back down through the veins. So those blood vessels experience different types of pressure. When that pressure is going up, we call that systole, or the systolic pressure. And when it's going back down, when your heart is resting, we call that diastole, or the diastolic pressure. So when you think about a blood pressure reading, let's say your blood pressure were 120/80. That would mean it's pumping 120 units of pressure in millimeters of mercury out as the blood's going out. And when the heart is resting, it's coming back with 80. So that those numbers tell us the amount of pressure. So what I'm actually feeling when I take my pulse is I'm feeling that pressure change in that artery as that blood's being pumped up through. And that'll tell me the rate that my heart beats. Now the rate that we use is measured in beats per minute. Now does that mean you have to stand here and count for a minute to be able to find your heart rate? No, you can break that down into smaller chunks. We know that a minute is 60 seconds. So a typical way to do this is to take your heartbeat for 15 seconds. So you'll need a stopwatch or some type of other timer to be able to count 15 seconds. And then you take whatever that rate is times 4, since 15 times 4 is 60. If I had a rate of 20 beats in 15 seconds, which would be pretty normal for me, then I would have a heart rate of 80 beats per minute. So you can calculate that heart rate taking a carotid pulse. The other place that we can take a pulse is inside of our arm. So if you think about your arm, you have a large artery that comes down through the top of your arm right here called the brachial artery, and then it branches off into two other little pieces. And the one that runs outside, kind of like a piece of tubing running down the inside of my arm right here, runs alongside the radius, and the other runs alongside the ulna. If I come down here to the radius, this bone I can feel right out here on the outside of my thumb, and I come down this bump right here, I should be able to feel that pulse right in this area where that artery comes close to the surface of the skin right through here. And I can feel that pulse coming right through there. Sometimes it can be a little farther forward or backward. Everybody's body is a little bit different, but it'll be somewhere right in this area. I can do the exact same thing there, and there I'm finding my radial pulse. Your radial pulse and your carotid pulse are going to be the same because they're both detecting that pressure change as your heart pumps. Every time it contracts, the pressure goes up, and every time it relaxes, that pressure goes down. So that's what we feel in our heartbeat as those things are moving around. The second thing you're going to be doing is looking at your respiration rate. Okay? So our heart is the one that's pumping our blood, but our lungs are the thing that's pumping the air in and out of our body. So as you breathe, you're drawing air with a higher concentration of oxygen into your lungs. That's getting absorbed into those tissues in the lungs and then passed into the blood vessels around the lungs, those little structures we call alveoli, passed into the capillaries and then carried out to the rest of your body, back to the heart and back to the rest of your body. So that oxygen goes into your blood, and then you are exhaling the carbon dioxide, getting rid of that as a waste product that your cells are creating. When you exercise, what happens to the rate of your breathing? So if you were to get up right now and run around your house five times and come back inside, you'd probably start breathing a little faster. That's a response, just like your heart rate going up, that God has given you to get more oxygen into those tissues. You've just burned a lot of energy, and the sugars and things that are reacting in your cells need oxygen to burn, and then they release CO2 in that respiration process inside of your cells, and that's going to be passed back to your blood, and then we exhale that. So God's given us this natural mechanism to help balance the amount of oxygen that we need to get in as our activity level increases. Okay? So you're going to be looking at both your breathing rates per minute and your heart rate, your beats per minute. So 2 different BPMs, breaths per minute and beats per minute, and compare how that works with different levels of activity. You're going to be taking these pieces of information, recording them in a table. You can do this by yourself, but it'd be best if you had a friend there to help you or another family member to help you run the timer and record some of the data that's happening. Now, we're only going to make you exercise for 10 minutes, but if you think about exercising, there are all types of different exercise that we can do, and you may have heard of aerobic exercise. So this is an example of a heart chart that you can find in different forms, and it gives us some information about age down here on the bottom and heart rate over here on this side, and talks about the heart rate and how we can get into different activity zones. So I'm age 45, so right here in the middle. So we'd expect my resting heart rate to be somewhere around 90 beats per minute. And I'm usually somewhere around 84, 85. And then if I wanted to do activity at a low level and burn some fat or weight control zone, there are different things these zones are called in different types of describing these exercises. But if I wanted to get what we call aerobic exercise, really burning lots of calories and consuming lots of oxygen, that's where that word aerobic comes from, is from oxygen, then I'd have to get my heart rate up to about 70 to 80% of its max. If I'm not doing that, I'm probably walking at a strong pace and I'm getting somewhere in one of these zones. This would be something like cycling pretty fast or going for a jog or a run. If I really wanted to burn those calories and get into this anaerobic zone, I'd have to increase my heart rate up to 80 to 90%. So this would be a very short duration thing that we do, something that maybe elite athletes would be training in this zone. But most people are going to be training in the aerobic or down here in one of these lower zones as they exercise. Okay, so let's talk about the data you're going to gather. You're going to be collecting both your heart rate and your respiration rate, your breathing rate, and then you're going to be putting those in a data table, and then you're going to graph that information. So as a scientist, when we run an experiment, we want it to be observable, repeatable, and testable. So we have in any experiment what we call variables. So you're going to learn a bit about variables in this experiment. The variables are the things that can change, and that's what the word variable means. So in an experiment, we're going to be measuring some variables, keeping some variables the same, and then we're going to be adjusting other variables. So if we think about the graph that you're going to be making as a result of this data, we think about a graph having an x-axis and a y-axis. We like to plot what we call the independent variable over here on the x-axis. This is the variable that the experimenter is going to change, and it's the one that we think of as the cause in the activity. So whatever's causing the effect, which is over here on the y-axis, we call that the dependent variable. It's the effect, and it's the one that the experimenter is typically measuring. So you're going to be creating a graph based on your independent and dependent variables. You're going to look at how that rate of or the length of your exercise changes the rates of those breathing and pulse measurements that you're going to be taking. Okay, so you're going to get to be the experimenter, collect that data, and then graph it out for us so we can see it pictorially represented. Another interesting thing you could do during this activity, you could try other types of things you could measure. If you have access to a blood pressure cuff, you could also do an experiment where you're measuring your blood pressure and other types of things that would possibly change during activity. Okay? Now let's stop for a second and think about what happens when you go to the doctor's office and they grab one of these stethoscope things and they put it inside their ears and they put it up to your heart and they're listening for those different sounds. Now, if you had a stethoscope, you could also use this to measure your heart rate. You could just put that here against your chest and be able to hear your heart rate, and that would also help you to calculate that. But most people don't have one of these. If you do, they're fun to see how your heart sounds and different things. Now, if you think about the heart, the way we talk about the heart, it had 4 different chambers. Okay, we've got the atria at the top and the ventricles down at the bottom. So the blood's coming in here to the atrium, to the ventricle on the right side, and it's going out to the lungs and back into the atrium, back into the ventricle, and then back out through the aorta. All of those things, the way that that heart pumps the blood, remember that there are little valves inside of here. So we've got a valve, this one right here, that's actually preventing the blood from flowing back from the ventricle into the atrium. So when a doctor is listening to your heart, or maybe a nurse or some other person, healthcare professional, they're actually listening for those valves opening and closing. And if you can see over here on Aortic, I've got some stickers placed. Now you may have noticed the doctor just doesn't put his stethoscope on and stick it right there in the middle of your chest. He actually moves it around to different places. And these little stickers, that one's about to fall off, actually tell us about the different valves, the different sounds. So if he wants to listen to the aortic valve sound, he'll put the stethoscope in this position where I have the A sticker. It's in between the second and third ribs. That we call that the second intercostal space. It's that second gap in your ribs, and you can feel that if you run your finger down your rib cage. Over here, he can hear the sound of that pulmonic valve, and then down here, he hears the sound of the tricuspid valve, and over here, the mitral valve, all of those different things. So if you have access to a stethoscope, you could actually use that during your activity and hear how your heart sounds change as well. All right, we hope you have a great time exploring your heart and your respiration with this activity. Remember to take good notes, record good data, and then graph those things out carefully so you can look at those trends. And until we see you next time, get out and explore all of God's amazing creation.